raising excellence.
Subscribe to our channel and click on the bell icon to get trending courses for free.
In this module, we are going to discuss using Python, text pre-processing. We are going to implement stemming and lemmatization. Then at the same time, we will try to remove stop words and we will try to treat missing value problem. Yeah. So basically this code we have written using the class and the functions format. So what we are going to do is here you can see that we have defined a list self underscore reviews. In this particular list, we have 4 reviews, which we are going to use as a raw data, or you can say these 4 reviews we are going to use for training our vectors. Okay. And then we have defined a new variable self underscore test underscore reviews, which is again a list where we have 2 reviews. So we are going to be using these sentences for our test data set. Means we train our vectors on the self underscore reviews, and then whatever reviews we have in self dot test underscore reviews, we are going to be converting these 2 sentences into mathematical vectors. For this, what we need is we need to import these 2 functions, which are count vectorizer and tfid of vectorizer from scikit-learn. Then at the same time, we need to import Potter's stemmer from NLTK, WordNet lemmatizer, this is for lemmatization from NLTK, and stop words from NLTK.corpus. Okay, so first what we are going to do is here you can see that first we need to clean our reviews. Okay, so we are going to be using this function self.clean underscore data, which we have defined in this code. We'll discuss that shortly. So what we'll do is using that same function, we are going to clean or remove the noises, or you can say in data science term, we're going to pre-process all the sentences which are part of self.reviews. And at the same time, we're going to be applying same pre-processing steps on our test underscore reviews. Okay, so let's see what are the different steps we have in our clean underscore data. You can see here we have defined a function where input is what? List of reviews. Okay, so first of all, what we need to do is we need to create one object, ps equal to Potter stemmer. So this is what we are going to use when it comes to stemming. Okay, then we have defined an empty list, clean underscore list underscore of reviews, where we will simply append all our clean reviews after pre-processing. So first, let's write a loop in this line. We are writing a loop on all the reviews which are part of list of reviews. Then we are simply applying a split. So what is this function is split? Say in a sentence, if we have multiple words and if we apply dot split function on it, it will simply split the sentences on words. Okay. By default, if you don't specify anything inside this function, by default, it will split your sentences on spaces. Okay. Then again, we have defined an empty list, clean underscore reviews. Okay. So if we try to understand list of reviews where we will have multiple reviews. Okay. So we are gonna loop on all these reviews. Then we have review dot split. So sorry, we have review dot split. So this split function will split all the sentences into words. And after that, clean review. Clean review is what? An empty list. Now for word in review, what we are doing is, if you see, first of all, convert that word into a string, then you apply a dot lower function. What is use of this function? This will convert all caps into lower case. Okay, then set self dot stop words. So basically, if you see, we have imported this from our NLTK library, and here we are saying self.stop words equal to stop words. This is from NLTK library. You can see here dot words, and here you need to specify the language. So basically this will give us all the stop words which are part of English language according to NLTK library. Okay. Yeah. So we are saying first if we try to understand this entire line, first you convert the words in lowercase, and then if they are not in stop words, then only in this clean review append the word after applying a stemming. Okay, so this is what ps.stem. So dot stem function is what we can use for applying simply any stemming. Okay, so this loop is on all the reviews whatever we have in the say list, and this loop is for all the words in a single review. So what happens is after each loop in our clean review, we are going to have words in lowercase if they are not part of stop words and after applying stemming. Okay, so clean review is what? All the pre-processed words in a sentence. Everything is going to be in the lowercase. Then words are going to be part of clean review only if they are not part of stop words and after applying stemming, right? So what, as of now, all the words are what? Nothing but they are present as individual words in this list. But then what we need to combine all these things to form a sentence. And how we do that? We have this dot join function which will simply join our words in a list. Okay, and what is this? This is simply that, hey, all the words in this clean underscore review, we need to join using spaces. Okay, so now clean review is what? Nothing but pre-processed review. And this one is our final pre-processed review. So we need to append that in our global list, which is clean underscore list underscore of reviews dot append clean review. Okay. And once you are done with all the reviews, simply what we need to do, we need to return clean list of reviews. Okay, so if we summarize, what are the different components which we are applying, or what are the different pre-processing which we are applying? We are applying lowercase, then we are checking if a word is part of stop words, we are discarding it, and we are also applying stemming on top of it. Okay, so as of now we have discussed split function, stemming, removing stop words and lowercase. So let's try to understand that. So here also, if you see, not required in this case. So we are importing Potter's stemmer from NLTK, then word lematizer and stop words. Okay, we are importing all these from NLTK. So say if we have a sentence, test underscore sentence, where we have defined data is the new oil, we should start practicing data science, right? So let's execute this. Now, first of all, if you want to apply pre-processing and say if you want to convert all these things into the lowercase and we want to retain only the words which are not part of the stop words, and we also want to apply, say, stemming. So first of all, what we'll have to do? We'll have to split these sentences into words. So what's the function for that? See, split sentence equal to test sentence, and this is the function dot split, which we are applying on test sentence. By default, if you don't give anything here, by default, it's gonna split the sentences on spaces, right? So if we execute this and print split underscore sentence, let's check the output. What we have? All the words now comma separated. So test underscore sentence is, split underscore sentence, nothing but list of all the words which are part of our test underscore sentence. Data, then is, then the, and all these things. Now let's do one thing. So we are done with this. Potter stemmer, first of all, we'll have to define one object. So PS equal to Potter stemmer. Then clean list, we have defined one clean underscore list for words in split sentence, which is nothing but this thing. This is our split sentence now, right? Lower form equal to words dot lower. So this is the function which we can use for applying lowercase. Then say if you want to apply stemming, then ps dot stem, and input is the words on which you want to apply stemming. So we're going to be using lower form. And then once we have applied lower and stemming, you simply append the word in our clean underscore list. So here we are printing the original word, then the lower form, and then stemmed word, right? And then finally we have the clean underscore list. So let's check the output. If you see, data after lowercase is a small d and stemming is same, age is also same. But then say if we talk about practicing, right? Practicing is what? After lowercase, it's practicing, but then after say a stemming, only C, ing is getting removed. And you know that stemming is what? a hard way of normalizing these words. Similarly, in science, if you see after lowercase, you have a small s, but then last E is getting discarded because of stemming. And finally, if you try to compare this with the original one, right, which is this, clearly we can see that all the words now we have is what? In lower form, and at the same time after applying a stemming. So practicing is now practice and science is now as science. Okay. So now we have list of words after stemming and lowercase. But then still what we need to do? We need to remove all the stop words, right? So stop words equal to set stop words dot words, and then you need to provide this function. Okay, sorry, not function, this argument, which is English, means we want to import all the words which are part of stop words from English language. Okay, and this comes from your NLTK. If you see stop words. So say if I print all these stop words, these are the words which are part of NLTK English language. Okay. So you can see words like this, to, whom, lil, and all these things you have in, you can find is, the, not, and all the other words which are going to be part of your stop words. Okay. Okay. So now if you see in this clean list, we have all the words which are in lowercase and after applying is stemming. So what we need to do, we simply need to discard all the words in this list which are part of our stop words. So for word in clean underscore list, if word in stop word, then pass. If it is not in stop word, else minus a stop word, which we have defined here, append the word. So if you check the output, so this is what our original raw data after applying stemming and lemmatization. But then now after removing the words which are part of stop words, we have words like data, is, and the. It's getting discarded. Why? Because they are part of the stop words. Let's try to find is and the. See, is present here, right? Similarly, if we need to find the, I won't spend too much time. Okay. So these words are getting discarded as stop word. New is present there. Oil is also there. Comma is also there. We is again getting discarded. Should is also getting discarded. Start is present, practice is present, data and science. So basically words like is, the, we, and should are getting discarded. Why? Because they are part of the stop words. So now we have this minus underscore stop underscore words is what? Nothing but a list where we have all the words which are say in lowercase after applying stemming, and if they are not part of the stop words. Now what we need to do? We need to simply join them. So what is the meaning of this? That we are going to join all the words which are part of minus underscore stop words. And how exactly are we going to concatenate or join these words? Using spaces. So if you check the output, now you have a single sentence: data, new oil, start, practice, data, science. Okay. So yeah, these are the end of our pre-processing on text data, right? Next, we will discuss how to vectorize. Okay, cool. So basically, what exactly we are doing? We are cleaning all the 4 sentences which are part of our self underscore reviews and the 2 sentences which are part of our test underscore reviews, right? You can see we have defined self underscore reviews here where we have 4 reviews in this list. And then we have 2 reviews which are part of our test underscore reviews. So let's go ahead and start the vectorization process. So we are going to use count vectorizer. This is the function which we can use from an scikit-learn for our bag of words vectors. So first of all, you define one object of type count vectorizer. Then this function dot fit. Okay. So dot fit is the function defined in sklearn which we can use for training our vectors, right? And then input is what? Clean underscore reviews. So let's check the output. So clearly here we can see that words like bought, product, good, worth, recommend, and everyone are going to be part of our feature set, or these are the words which we are going to use when it comes to defining our vectors for the sentences or a string, whatever we have, right? So what is the meaning of these numbers? It says that, hey, in our vector, the first position will denote bought, The second position is for word everyone. The third position is for word good. The fourth position is for word product. And then the fifth position is for word recommend. And the sixth one is for word worth. Okay. So these are the words which are going to be part of our feature list, right? Okay. So now say if you want to convert or if you want a mathematical vector for a sentence, okay. What's the syntax? Count vectorizer, the one which we have trained, dot transform. So this function is what we need to use when we need a mathematical vector. And then clean underscore test underscore reviews. What is this? List of all the clean reviews. And we know that in this, what we have is 2 reviews. So once we print this train underscore vectors underscore 1, dot to array is simply, you can say, in a human readable format. So basically this will give us the vector of, or say count vectorizer, a bag of word for the 2 reviews which are part of our self underscore test underscore reviews. So let's check the output. If you see words like bought, product, good, worth, recommend, and everyone, these are the words which are part of our feature list, right? Or the words or the unique words, you can say, which are going to define our vectors. So total we have 6. So we have 2 sentences. And if you can compare the length of these 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So length of vector is what? So these are all your unique words, right? Now, what is the meaning of all these numbers? It's like, hey, word bought is present once. We are talking about bag of word approach, right? Then what is the meaning of this 0? That at position 2 we have everyone. So word everyone is not present in the first sentence of our, say, self underscore test underscore reviews. We can also verify that. So now we can see these are the 2 reviews for which we have simply constructed our count vectorizer, or say bag of word vectors. So word bought is present. Why? Because the index is what? 0. So basically this is index 0, this is 1, this is 2, 3, 4, and 5. Sorry, one second, guys. So let's make it 4 and then 5. So 0 is 1 means word bought should be present in our first review. Then word everyone, which for which the index is 1, is not present. And you can see that in this particular sentence, word review everyone is not present. See, if we need to compare this one, what is the index? 0, 1, 2, and 3. And 3 is for what? Product. So for sure, in the first review, we should have product coming twice. So product and product. So this is our bag of word approach. Okay. And clearly you can see that here word add is not present. Why? Because we have trained our vectors using the first 4 reviews, and word add is not present there. So word add is not part of the unique words or the feature set which we have defined using these 4 reviews. So of course your count vectorizer will end up discarding this word add. Okay. And what is going to be the vector for the second sentence? 1, because word everyone is present. Then 1, 1, which is like 3 and 4, means word like product and recommend. So yes, we have word like product and recommend. All these things are getting removed. Why? Because while cleaning, we have discarded all the stop words. So this is how we can simply get, say, bag of word vectors for our sentences. Okay. Similarly, when we need to create a, say, TF-IDF vector, the syntaxes are going to be the same. The only difference is now what we need to do is we need to define a TF-IDF underscore vectorizer object. Okay. And then dot fit. Again, we're going to define our vectors using clean underscore reviews. And you know that in this list, we have 4 sentences. So dot fit will simply give us the trained vectorizers. Okay. Now, dot underscore vocabulary will give all the words which are part of the vocabulary, or you can say in simple terms the unique words which are going to be the same. And then if we need to convert, say, a text into a mathematical vector, the function is dot transform, clean underscore test underscore reviews. So again, what we are doing, TF-IDF vectorizer, TF-IDF underscore vectorizer, which we defined here. Okay, using this, transform all the sentences which are part of this list into a mathematical TF-IDF vector. So let's check the output. And you know that toArray will simply give us all the numbers in an array format, which is easy for human readable. So what we'll do is, let's try that. Again, we can see our vocabulary is going to be the same. Words like bought, product, good, worth, recommend, and everyone. Index is also same. But then now we have some numbers which are in, you can say, some real numbers. Why? Because you know that when it comes to TF IDF, what we do, first we calculate TF, then IDF. TF is what? Frequency of a word divided by total number of words. And IDF is what? Log of total number of document divided by total number of documents in which a word is present. And then we multiply these two numbers, TF IDF. And what we get is nothing but the TF IDF numbers. It's very easy to kind of validate why these numbers are 0. It can happen because if TF is 0, or say if IDF is 0, right? So let's verify for a few of them. It's saying that, okay, let's index it 0, 1, 2, 3, 4, and 5. 5 is saying 0, 0. So worth, okay. So let's check. Yes, of course, word worth is not present in the first sentence, nor in the second. Similarly, say if we need to verify for this one, the index number is 2, which is for word good. So if it is 0, let's check. Yes, of course, word good is not present. Yeah. So the key takeaway should be that first of all, we'll have to define the count vectorizer and TF-IDF vectorizer, and then the function dot fit and dot transform. So dot fit is the function which we can use for, say, defining our count vectorizers, or say the bag of word vectors, and transform is what we can use once we have a trained vectorizer for converting any text into, or any sentences into, a mathematical vector. Thanks.